Oh boy. So we have the floor function. To recall, for those who don't know what a floor function is, uh, it's pretty much like if you get some like a real number, right, or something, whatever, it just turns it into a whole number, and it rounds it down, right? No matter even if it's like 3.7, it rounds it straight down. That's all it is. And then graphically, a floor function would be like, let's see, from 0 to 1, 2, 3, 4, 1, 2, 3. All right. So like from 0 to 1, it's going to be 0 because you're rounding it down. And then from 1, you're rounding it down here. Then 2, you're rounding it down here. And 3. That's what a floor function would look like graphically. Now, if you know me very well, I hate graphs. Um, well, I hate graphing. I'm definitely not going to graph this function here. That's nasty. And uh, usually because it looks like this, right? Finding the area is kind of like you're adding these rectangles. It's a very bad, that's a very bad integration drawing, but uh, you're just adding rectangles. And because these are like rectangles, uh, we usually integrate this into a sum formation because it's just more straightforward that way. Now, I don't like this because that's nasty, so I'm gonna turn this whole that is a very terrible curly bracket. This thing here, I need that to turn into like just a variable. Uh, you'll see why. So we're gonna let u equal root 10, then u10 is equal to x, 10u9 is equal to dx, u, right? Okay, so now we get, let's see, we have plugging in 1, we get plug in root 10, 2020, we get 10u9 du, and then floor function of u at the bottom. Okay, now it's just a variable. Cool. That's what we want. We want it lonely so that now we could turn it into a sum. So this goes to, oh shoot, that might not be an integer. 2 to the power of 10 is equal to, what's 2 to the power of 10? 32, 64, 128, 56, 5, 5, 1024. This is 1024. Oh God. This is for, wait, okay, wait. 3, 4 is equal to 81. So then the eighth is going to equal to 81 square, which is definitely going to be 81 square. That's more than what, 6400? Because 80 square is 6400. So definitely 310 is going to be like the maximum we're going to reach. Okay. So in that case, we're not going to do this u substitution because this bound uh, kills it, or not kills it. It just ruins this whole method. So instead, at this point, we'll be splitting it up, right? We'll be splitting it up. Uh, this goes uh, uh, more than. That's not a more than. Uh, this is more than 2020 for sure. So is 1. Okay. So then at this point, we just split it up. We technically split this up. Right? So if you're going to do it manually, this is the manual way. This is the manual way. And we are technically splitting up manually. So now from 1 to 1024, 1024. The reason why this is not 2 is because when we, if I plug in, let's say like somewhere between, like I said, like the domain 1 to 20, 1024, between these numbers, let's say like 600, right? 600, right? Then 600 is less than 2 to the power of 10. So this is going to equal to 1, right? In fact, any numbers between 1 and 1024, put it in here, and then the floor function, round it down, it's going to be 1. So this is supposed to be 1. And then this is supposed to be 2. This is 2. I messed up. So, I'm sorry. No, this is... So, this... the floor function is at the bottom. So it's 1 over 1, 1 over 2. That's how it works. I'm so sorry. Because this whole floor function is at the bottom. So that's how it works. So it's 1 over 1, 1 over 2. Then this is 1023 plus a half of, what was it? It was like uh 996, right? And then this is equal to 1023 plus God, I can't do this in my head. It's 8. That is not 8, that's 9. That's 8. 498. Now this equals to 1023, 498, 11, 3, 12, 15, 21. That is the answer.